Alright, so we're going to have a look at a little bit of a deeper example. So going beyond just find the equation, we're going to have a look at this one here. So find the equations, notice you're going to have two answers at the end here, of the tangents to the curve y equals 1/3 x cubed plus x squared minus x plus 4 at the points where they are perpendicular to x plus 2y is equal to 3. Okay. Now we can't just kind of do the blind process that we did with the other examples because we don't have an x value. Okay, so it just says where they are perpendicular. We don't actually know, is that at x equals 7? Is that at x equals 2? We don't know. We need to find that out kind of as a starting point. So we do notice this is an important piece of information here. So we're looking where it's perpendicular to this line here, x plus 2y is equal to 3. That's kind of code for where the gradients of the tangent are what. Okay, so let's have a look at this equation here. X plus 2y is equal to 3. Well, if I want to talk about perpendicular parallel, it's important to be able to clearly see the gradient. So let's rearrange this. So let's subtract the x over, so I get 2y is negative x plus 3, and then dividing through by the 2 to get that y is negative x over 2 plus 3 over 2. So hopefully from this we can all recognize that the gradient of that line that we're comparing it to is negative 1/2. So if the question had said at the points where it's parallel to that line, that would be what our gradient of our tangents would be. However, that's not what it says. It says where it's perpendicular. So remember, perpendicular, this would be similar to if it had said find the normals. Okay. When something's perpendicular, we need to take the negative reciprocal, so flip it upside down and change the sign. So in this case, perp, okay, so the perpendicular gradient, or the gradient of our tangents, is going to be 2. Okay, so this is a bit of a different way to figure out what the gradients are. We used this other line. So now that I have a solid piece of information, the gradients of my tangents are 2, or is 2. Okay, and that's going to be for both of them. So I've got my gradients, happy. Now I need to find the points. I'm actually going to have to do a little bit of work to find those. I'm going to have to solve where the gradient is equal to 2. Okay, so determine the x values when the gradient is 2. So pause, have a think about how we might do that. Based on the function g of x, how can I figure out when the gradient of g of x is equal to 2? Okay, thinking context, we're looking at calculus, I should probably take the derivative. Okay, so taking the derivative of g of x, I get g dashed x is x squared. Again, the reason I put this third here in the question is so that when you bring down the 3, you end up with 3 over 3, which is just 1, leaving me with x squared. Okay, so I get some nice pretty numbers. Bring the 2 down to give me 2x, and then negative x. Again, the power is reduced to negative 1. Well, this is essentially the equation for the gradient. When is that 2? Well, I'm looking to solve for the x value, so let's try and use our null factor law. Move the 2 over by subtracting. So subtracting 2, okay, to get this lovely equation here. Thinking back about solving, let's factorize it. So two numbers that add to 2 and multiply to negative 3. Well, that's plus 3 and minus 1. Meaning that the x values are negative 3 and positive 1. So I know my gradient is 2 for both of my tangents, and that the tangents I'm looking for are at x equals negative 3 and x equals 1. Again, those are just the x coordinates. I also need the y coordinates so that I can plug those in. So this is just a little bit kind of a backwards, little bit of problem solving that I had to solve for the x values given the gradient instead of figuring out the gradient given the x values. So just solving backwards. So my gradient is 2, I've got my x coordinates, let's find the y coordinate. So just kind of quickly going through, always back to the original to find the coordinates of the point. So I plug negative 3 into g, do the arithmetic. Here I'm showing all of my working. So cubing negative 3, squaring negative 3, and then subtracting a negative is a plus. Collecting my like terms, I get 7. So negative 3, 7 is the point. The gradient will be 2. I've got all the information I need. I just need to do the arithmetic. Plugging in 1. Yay, fractions, my favorite thing. So I'll notice that I end up with a third plus 1 minus 1, so that cancels out. So I end up with a third plus 4. So why not on the next line rewrite 4 as 12 thirds? Okay, so writing it with a common denominator. So that means 13 thirds. So 1 and 13 thirds is the point. Again, gradient is 2. So it's essentially I have to solve side by side for my two lines. So at x equals negative 3, remember my point was negative 3, 7, and the gradient is 2. So I've just kind of done the calculation quickly here, plugging into to y equals mx plus c for m, plugging in negative 3 for x, 7 for y, solve for c. Ta-da! I get that c is equal to 13. Now I can go ahead and state my final equation. One of my tangents is y equals 2x plus 13. My other, again, is at the point 1, 13 over 3, has gradient 2, plugging all that in, working with fractions, which is totally fine as long as you have a common denominator. So just carefully looking through that calculation and stating my final line there as y equals 2x plus 7 over 3. Again, sometimes they'll write it in standard form, so they'll clear the fraction and have everything on one side. So do be prepared for when you're checking solutions that the equation may be rearranged to what you have if you've got it in slope-intercept form. So being prepared for that. So that's our little kind of problem-solving example where we had to solve for the x values based on some information that we were given about the gradients. Have a look at the homework. So we're looking at finding equations of tangents before we move on to some curve sketching. If you have any questions, let me know.